In this video, we're going to build an application architecture, not by drawing diagrams, but by collaborating with an AI assistant that understands architecture as code. We'll walk through the Build a COM Architecture tutorial from Finos, focusing specifically on the COM AI assistant, a tool that transforms business intent into a structured machine-readable architecture definition. If you're exploring AI native engineering, agentic workflows, or specification-driven development, this approach is something you'll want to understand. Before we jump into the demo, let's quickly look at what we'll cover. The goal here is to demonstrate how COM's AI assistant can help build and refine an application systems architecture. Instead of starting with diagrams, we'll work with a structured architecture definition expressed as code, and use the AI assistant to develop and improve it step by step. First, we'll set up the COM AI assistant and the supporting tools so everything is ready to work with the architecture definition. Next, we'll create an initial COM architecture from business process documentation. This shows how the AI assistant can take higher level descriptions of a system and translate them into a structured architecture model. Then we'll enhance the architecture with more detailed technical information, pulling insights from the application's codebase and adding control specifications such as security requirements. Finally, we'll use the structured architecture definition to automatically generate architecture documentation. So by the end of this walkthrough, you'll see how COM and its AI assistant can help turn architecture into a living machine-readable artifact that evolves alongside the system itself. Now, let's get started. A quick note about this demonstration. This video follows the COM Practitioner's tutorial, which walks through building an architecture definition for the Finos TraderX sample trading application. TraderX is designed to be a distributed reference application in the financial services domain, which can serve as a starting point for experimentation with various techniques and other open source projects such as COM. One thing to keep in mind is that the COM AI assistant uses large language models. LLMs are non-deterministic, which means the responses they generate can vary from run to run. Because of that, the outputs you see in this video may differ slightly from the one shown in the practitioner's tutorial. If you want to follow along yourself, links to the tutorial and the TraderX project are included in the description of this video. First, we'll look at the business context for the architecture. This section describes the business scenario that the system supports. Rather than starting with the technical details, we begin by understanding the business processes and interactions that the application must enable. As we scroll through the page, you can see the description of the business environment and how users interact with the system. We'll use this business context to create the initial COM architecture. The information described here helps identify the required elements of the architecture, things like systems involved, the actors that interact with them, and the key relationships between those components. Starting with the business context ensures that the architecture reflects what the system needs to accomplish before we begin defining the technical implementation. In a subsequent step, we'll use this information to generate the initial COM architecture definition with the AI assistant. Next, let's set up the VS Code to enable COM's AI assistant and supporting tools. We're assuming the COM CLI has already been installed and is available on your system. Now, let's confirm the VS Code IDE is set up to work with COM. First, let's check that the COM tool extension is available. To do that, let's go to the extension and then just search for COM tool. And here you can see it's here. And in my case, I've already installed it previously. If yours is not installed, you should see a blue install button. Click on that to install the COM extension. Next, let's initialize the COM AI assistant in your workspace with the following command. Go to the terminal, COM AI dash provider copilot. And you should then see a series of messages similar to these, which indicates the Copilot AI assistant has been successfully initialized in your environment. To now make use of it, you then click on the Copilot chat and select the Calm agent mode. All right, let's start off with creating a minimal Calm architecture file. We're going to use this prompt. Okay, now it's asking to validate the minimal architecture file. So with this GitHub Copilot is asking for permission. Since we'll be running the calm validate command numerous times during this demo, what I want to do is tell Copilot that it can run this exact command line in this workspace. Okay, so we won't be prompted for permission in the future. Okay, looks like the minimal file passed validation. So let's look at it. So it created a file, trading system architecture.json. And we have, yeah, it looks like it's the minimal one with empty nodes and empty relationships. Okay, so now we have a start of the file. So now let's start doing some analysis on the business context. What we want to do is identify candidate nodes and relationships from the business context. For that, we'll use this prompt. So here, the prompt itself is just basically saying examine the business context, look for calm nodes that can be used for an event-driven architecture that are implied by the business design. And we're only requiring it to use only information found in the business design. That way, the Copilot won't try and hallucinate some information that's not there, and to list each node with its type and short description. And we've appended to it the business functions. So the stuff that we looked at earlier on, it's the same information. We've just concatenated that information to the prompt that I walked you through. Okay. With this, we'll just let the agent do its thing. Okay, so let's see what the agent has come up with. So here are the candidate nodes that are implied by the business context. And these look reasonable. Okay. So again, a good practice is to always review what the Copilot, the AI assistant provides, just to make sure it's accurate, does not have any hallucinations. Okay, so now that we have the nodes, let's see what kind of business relationships are implied. So we'll run this prompt. What relationships are found in the business design? Candidate set of nodes and relationships. Let's now populate that to the architecture file. Right. For that, we'll use this prompt, update the COM architecture file with the nodes and relationships that it's identified. Looks like there might be some incomplete information here. Again, this is a trading system, so I think critical node would be, or party into this architecture would be reflecting the human trader. So it looks like we're missing the human trader that would be interacting with the web GUI. So let's ask the AI assistant to add a node and a relationship. All right, so here we're asking AI assistant to add a node called trader, who's an actor, and that to create a relationship, interacts relationship with the trader to the web GUI node. So let's let the AI assistant update the file and see what happens. So now this is where we can make use of the Calm toolbox. So there's a, you can see as we develop it, we can look at the COM toolbox, the architecture, and then with this we can ask to preview what are all the different uh, views of the architecture. So let's do a preview. So this is a we look at the possible commands, VS Code commands, and here we look for COM open preview. So this will open up the preview view of the toolbox. So here we're going to look at, let's just make this a little bit more. Here you can see, okay, so here we have the trader, we have the web GUI, we have the different services. This looks reasonable. Well, let's see, so this is the overall architecture. So let's look at one of the services. So let's look at the trade service. We click here on reveal and graph. This should give us a view of the trade service. Right, and this looks, yeah, this looks reasonable. Right, and then now let's look at a flow. Oh no, we don't have a flow yet. All right, so we have some architectures. All right. So now, given that we have the start of the architecture, and we're in the Git repo, let's now commit this as kind of our initial baseline. Right, so that looks good. So now that we have the nodes and relationships as the initial version, so now let's look at adding flows. All right, so what we're asking the AI assistant to do is to list candidate COM flows that are described in the business design. So let that go. Right, looks like it's coming up with the candidate flows. So here's one for load a list of accounts with all the steps in the flow. So now what we'll ask is for the AI assistant to add this to the architecture file. So add the flows to the trading system architecture file. Here we go. It added and it passed the validations. Okay, so that's good. So we'll keep this. So again, looking over the flows, in particular, looking at the submit trade ticket and the trade processing flow, this kind of seems to say that this starts off with the web GUI starting it, but it's actually a trader submitting a trade ticket that kicks off the flow, and when in processing the events, notifying the web GUI, but it's really the trader that needs to understand what trades have occurred. So for these two flows, and again, just focusing on these two flows, what we'd want to do is add add the role of the trader. Add this prompt. So what we're saying is add the trader node to the submit trade flow, where the trade interacts with the web GUI to submit the trade ticket, and then add trader to the process trade flow. Making sure submit trade ticket flow. Let's say trade ticket flow. And then here where the trader receives the notification from the trade processing. Here it's called the trade processing flow. So let's correct this. Trade processing flow. Right. Where the trader receives the notification at the end. Okay, for this, I'm also asking it not to update the architecture file at the moment, that I want to be able to review and approve any changes before they're actually made to the file. Okay, here we see that for the submit trade ticket, we now have a step from the trader to the web GUI to initiate the trade. And if we look at the processing flow, we should see at the end where there's now the web GUI trader receives a notifications. Okay, so this looks reasonable. And then we'll tell the agent to make the change. So this looks good, right? And that it also says it's passed, no errors or warnings. So that's good. All right. So with this in mind, so let's commit the changes. And now what we can do again is using the column toolbox. Let's look at the overall, look at some of the flows that got added. So these are the new things that were added. So again, we can do a preview where we can see, all right, this is, here we go. So we have the process flows. Let's look at the two that we had modified. So this is maybe difficult to see, but here we have the trader that was part of that was added to this flow. And then the trade processing, we can see at the end, the trader is here. So yeah, we can see that. Let's go back to submitting trade ticket. Make this a little bit bigger. So we can see the trader node was there, added, and now this is the rest of the processing of the flow. All right, so this looks good. All right, so we now have, and then if we look at the overall architecture again, let's see, let's make this a little bit bigger. All right, we can see we have the trader, web GUI, and again, this is just the overall architecture. All right, so this looks good. All right, with that, we have added flows, we've added the nodes and the relationships. So now we have a baseline of the architecture that represents the business context. So the next step in this is to look at, to enhance the architecture with some technical details. Okay, we're going to now enhance the architecture definition with some technical and non-functional requirements. All right, so first, what we want to do is document the interfaces for the services in this architecture. So for that, we'll use this prompt. So what we're doing here is asking the AI assistant to just focus on the nodes that are services. Okay, and it looks like it's correctly identified the 7 services. All right, so with that context, we're going to ask it now. Okay, so for each service listed, identify the service endpoints in the codebase. So hashtag codebase is the keyword for GitHub Copilot to look in the code repository. For each endpoint, extract the following information: the description, path, method, and port. And if you're unable to find endpoint information for the service in the code, respond unable to find endpoint information. Again, this last part here is to help minimize the chances of the AI assistant hallucinating incorrect information. All right, and here it's coming back with what it's reported for the account service, the port, the different endpoints, the methods, trade service, position service, trade processor, security master, people service, and trade feed. And it looks like with the trade feed, it's not a REST interface, it's a WebSocket interface. All right, so what we want to do is probably handle this in two parts. First, the endpoints that are RESTful endpoints. So for that, what we'll do is use this point, except for the trade feed service, propose endpoint COM interface specifications for the node, show the recommendation. I want to review and approve changes. Again, my typical way of working with the AI assistant is to have it come back with a proposal. I look at it. If it's good, then I'll say update the file. If not, then I'll just continue engaging in a conversation with the AI assistant to massage the proposal until it's in a form that I like. Right, so now, since the proposal looks reasonable to me, I'll have the AI assistant update the architecture file. Right, so it added it, but it didn't look like it ran the validate command. So let's ask the AI assistant to validate the architecture. This looks reasonable. All right, so now we have the RESTful interfaces specified. So now let's go back to the one for the trade feed. All right, so that's a WebSocket one. So let's use this prompt. All right, so for the trade feed service, propose a COM interface specification. Again, display the proposal. I want to review and approve any changes. All right, so we'll let that go. This looks reasonable. We'll say yes. And all right, and it validated, so we're looking good. All right, so here, now since we've made updates to the architecture, so let's commit this to the repo. All right, there we go. Now I noticed that in doing this last bit, that the context window for GitHub Copilot is getting kind of full. So what I'm going to do is start a new session before continuing, and then so that we can start with a clean context window. But before continuing on, let's look at what we've defined to the COM architecture. So for the nodes, let's say for the service nodes, we've added interface information. So let's see from a preview perspective, what does that look like? All right, so here's a trade service. So it looks like let's reload the windows. Sometimes the COM tool gets hung, and what we need to do is just reload the windows. Let's look at previews. Okay, this looks much better. Right, so let's look at some of the nodes that we added interfaces to. Let's do this. All right. Related nodes, and this looks reasonable. Here's the interface view. All right. All right, so this looks reasonable. All right. All right, so now let's continue on. What we'll do is add some non-functional requirements related to controls. What we want to do is this prompt, and then what we want to do is add architectural level controls dealing with encryption in transit, and these are the specifications for that, and encryption at rest, and these are the specifications for that. Okay, so we'll do this. All right, it says it passed the schema validation, and looks like I misspelled the name. Okay, so that's yeah, helpful of the AI assistant that it knew what I wanted, even though I misspelled it. So we'll say keep this. The thing I'll point out here, though, is for example, this is the AI assistant just filled it in because this is part of the specification. But for real work, this is where you would have to put in your own company specific information. Okay, so we now have some controls in place. So let's commit this to the repo. Okay, so now we want to add some metadata. All right, so we'll to the architecture, so we'll do this. All right, so we're going to add the following metadata at the architecture level. We'll put the name trading system, description, here's it is, it's a version, and that it's created by the trading system team Copilot. All right, we'll let that go. Let's make sure we commit this to the repo. Okay, the last thing we want to do is now document the trading system boundary. So for this, we'll make use of this prompt. So we're going to add a node called trading system that is of type system and create a composed of relationship that adds all the nodes except for trader user directory to the trading system node. Okay, so basically all the services. Okay, here we have the trading. Okay, so this is the new composed of relationship that was added. Okay, so we'll keep this. And then let's see what it looks like from an architecture perspective. All right, so here we have the trading system. All right, so that looks right. The trader is outside of the trading system. The user directory is outside of that. So everything else is within the system boundary of the trading system. All right, so this looks reasonable. All right, so we're gonna accept that and commit this last change. Okay, at this point, we've now enhanced the architecture with technical information relating to the interface endpoints. We've updated some non-functional requirements relating to controls around data in transit, encryption, data in transit, and data at rest. We've also updated the metadata related to the architecture. And finally, we've better delineated the scope of the architecture itself relating to the trading system boundary. I'll now demonstrate two ways to generate viewable architecture documentation. The first method generates content that is viewable via a web browser. So for that, we'll use this prompt. And again, we'll make sure that the Copilot chat is still in on mode, and we'll put it into this directory called trade docs, HTML. All right, so now let's run the development server and view the content. Let's see, we'll do HTML, and then we'll do npm run start. Okay, it looks like it's building the client side, so that will take a little bit. Oh, and it's finished. And now the architecture content is now viewable. So here we can see the high-level architecture. Close. And we can see the metadata associated with the architecture. Right? And here are the nodes. So we can look at like the trade processor. Let's look at one, for example, trade processor. You see the information. You see the interface definition saying it's a REST protocol. And here are the methods, port number, okay. And here are the related nodes for that. All right. So the other interesting thing to look at would be flows. All right, so let's look at a submitting trade ticket flow. Here we have, and we can see sequence diagram where the trader submitting to the web GUI, working its way through the other services. Okay, so again, this looks good. So here's one way of looking at the architecture, generate architecture through the web browser. The second method uses Calm's templating function to create a custom markdown view of the architecture. A detailed discussion of Calm templating and how to create one is beyond the scope of this particular tutorial. In this section, we'll assume that there's a template file that's already been created called solution-architecture-mark document.md. That describes the what the form of the architecture output should look like. So let's take a look at it. So here it is. And what this is a templating capability based on handlebars. So this describes what's the content should be extracted out of the architecture document and placed in the generated file. So with that, we'll now make use of this. So for that, let's open this up a little bit. Let me start a new terminal. All right, so we'll run this command. So here we're running the calm dockify command, specifying the calm architecture file, saying we want to generate an output document, and that we're going to use this template called solution-architecture-document MD. Right? Okay, and this looks like this worked. So now let's look at the generated document. Here we go. This is what was generated. Let's just open this up in preview mode. And what you can see is this is the preview of the generated markdown file. We have the architecture metadata. We have the system's architecture. I love architecture. We document what are the architecture level controls, some statistics about the architecture like the number of nodes, relationships and flows. And now we go into detail for each of the nodes. And now we have the business flows. All right. So here's an example of one architecture file, one Calm architecture file that now can be used for several different purposes. One, create a web viewable architecture documentation, or generate a markdown file for that particular architecture. To finish up, let's summarize what we covered in this tutorial. We began with a business context description that captures the intent of the system. This business description becomes the foundation for generating the architecture. Next, we use the Calm AI assistant to generate an initial architecture model. We then refine the model by incorporating technical details from the application codebase and adding control information. We also saw how a single architecture as code file can be used to produce multiple views of the architecture. There are also some important best practices when working with Calm and the AI assistant. Use the AI assistant to bootstrap the architecture, but always review and refine the results. Iteratively evolve the model by adding nodes, relationships, and properties as the systems become better understood. Manage the architecture definition as architecture as code in version control, and use Calm tooling to validate the architecture and maintain consistency as it evolves. Thank you for your time. If you like this video, please like and subscribe.